Hello there, this is Nele from Toolchefs and welcome to this new video for the Stadium series. So what we're going to do now is we're going to have a look at a behavior tree and how we can use that for randomizing or even anyway driving our crowds. If you haven't checked the videos for the behavior trees for the behavior tree that we have done previously, I would recommend checking them because we're not going to cover all the fundamentals in this video. So first, I'm going to use the Atoms agent, so I'm going to import the scene.json for the Atoms agents now. And the first thing I'm going to do is I'm going to open the Atoms UI, and for the agent type, the man, I'm going to set the man stadium state machine, because of course we need to use that one for the stadium. Then I'm going to create an agent group. I'm going to assign a stadium layout and a state machine. Then here what we're going to do is we're going to just hide all sections except this one, and then I'm going to display the skin mode 6. I'm going to show the textures, and I'm going to set them all to sit, and I'm going to explain why in a second, but anyway. So before we start here, we need to set the state, this option, the set state on agent creation only to on, because we're going to change the state with a behavior tree. So we don't want our behavior tree to fight with the state machine behavior module. So I would recommend checking this. So I'm going to save this scene. Now I'm going to open the Atoms UI, and I'm going to go in the behavior tree tab. Actually, let me just make this a bit bigger, like this. And I'm going to create a new behavior tree. I'm going to call it stadium BT. Something like this. I'm going to save it. Also save the scene. And now we can start with the behavior tree. So with a behavior tree, we start with a root, and then we're going to define a tree that, depending on certain condition and the nodes that we're going to place in this behavior tree, is going to evaluate certain branches instead of others. And then in that way, we're going to be able to drive our crowds. So the first node that I'm going to add is going to be a repeat, and I'm going to add also a conditional, an optional. That's what I meant. I'm adding these two nodes, and I'm also going to set the repeat forever on the repeat, because what I want to do is, like, I want this behavior tree to be continuously evaluated at every frame, and I don't want this to exit ever. So the optional will make sure that the return value that is going to be returned by by its child is always going to be converted to success. And the repeat node will always make sure that this graph is always this tree is always evaluated at every frame. If you don't have, if you don't add like one of these two nodes, so if you don't have both in your behavior tree at this level, so just after the root, it might be that your behavior tree will exit after some frames and so on. So just for this case, this is what I'm adding here. Another thing that you maybe have noticed, that if I hover the mouse on these nodes, I see the tooltips. If you don't see the tooltips, it's because you have not set the right preference on Maya. So if you go here, and I think it's under settings, display help. So in the help you find the display tooltip, so you have to enable this one. And then after that is enabled, you will be able to see tooltips, which are pretty useful with the behavior tree, because you'll be able to see what a node does by just hovering the mouse. Okay, great. So at this point now, what we want to do is we're going to just create a very simple behavior tree for setting a state on our agents. And to do that, what we're going to do is we're going to add blackboard key. We're going to call it first. And then we're going to set this type to Boolean. So a blackboard is just acts as a container for variables. And then a blackboard key is actually a variable, which then you can give to this variable a name. So in this case, it's first, and then a type Boolean. So a Boolean is just a true or false. So we're going to use this one because what I want to do is, like, we want to add a conditional here. And I want to run this branch under this conditional only at the first frame, okay? So to do that, we're gonna say, I want to compare the first blackboard key with this value, so it's true. So we're gonna say basically, whenever the first is true, the check type is equal. Okay, so this is correct. So we just say whenever first equal true, then we're gonna do something. In this case specifically, I'm gonna say I want to set a blackboard key, and I'm gonna set the state of the agent. So you can use the set blackboard key for setting the state, but you will have to expose that metadata to the behavior tree. So to do that, you can create a new blackboard key, call it state, set the type to int, and then set the agent metadata to link. So by doing this, what I did is quite simple actually. So I've created a blackboard key which has the same name of the metadata of the agent, so which is state, or clear until now, and then we have to set the same type of the metadata of the agent, which in this case is int, and then after setting the agent metadata to link, what this does is basically links the agent metadata to this blackboard key. So whenever you link a blackboard key, you find this icon here showing up. So basically this is what I've done, and of course you can find this name and also the type on the documentation on the metadata page. Okay, so now here we're gonna say I want to set the state, and I want to set the state to an int value which is gonna be 0, which is if I go here in the main stadium machine, so sit, which is the value that we set here, is 1, but the stand is 0, so the ID is 0. So basically I'm just gonna overwrite whatever I did here just to show you how to set a state. And then what I want to do is I want to, sorry, I forgot to put like another node here. So what I want to do here is I want to add a sequence like this. So a sequence basically will, it's a composite node. So a composite node can have any number of children, and will actually go through all its children. So in this case, I'm going to set here after this, a set blackboard key, another one. I'm gonna say I want to set first to be false. So basically after the first iteration, this conditional will fail. So basically the behavior tree will stop here. It won't go in here after the first iteration. Okay. So let me now add the behavior tree, and I'm going to say this one is my stadium BT. And as you can see, as soon as I set that, now the behavior tree is being evaluated, so we're setting a different state than the one that we had here in the state machine module. To debug, what you do with the behavior tree, usually having drawing the metadata in the viewport is pretty useful. So here, for instance, I want to show the state. I'm gonna press plus here, so now we see the state. And also another thing that you can do is you can also use the debugger. So if you go here in the behavior tree, here what you can do is you can see the behavior tree of any of the agents that are in the viewport. So here you have the ID of the agent, the group ID. So here I'm saying I want to see the behavior tree for the first agent. And then if I go to the next frame, we see that the conditional is failing. So now the behavior tree just reaches this point, and it basically on the following frames it doesn't do anything. Just keeps stopping there. Okay, so this was a very simple example just to show you that you can set states with the behavior tree. And now let's go and have a look at something a bit more complicated. Okay, so now that we've worked out how to do something quite simple, what we want to do is we want to make something a bit more interesting. So we're going to try to randomize the states of our agents throughout the simulations. So not just something that happens on the first frame. So I'm gonna go and open again the Atoms UI, and I'm gonna go in the behavior trees tab. I'll select that behavior tree that we did earlier. And what we want to do really is we want to make a separate branch here. So this is basically what is going to happen on the first frame. Let me create a comment node, and I'm going to move this up there like this. So first frame. Okay, so this is basically what happens on the first frame. We're going to make an active selector here. So the active selector is what we want to use because basically how it works is it's going to iterate through the children until basically it finds one that it runs successfully, and also at each frame it's going to check that any child that has like a higher priority than a child that is already running, basically it's not returning true, so success of running. So basically, well, we can break the evaluation of a branch that is already running in this way. Okay, so now we're going to make a sequence, and actually we could even make a conditional here. Actually, no, it should be okay. So we're gonna make a sequence, and we're going to under the sequence, the first node that we're gonna add is gonna be a set agent metadata, and we're going to add the metadata name to be force clip transition. And as you might know already, this metadata makes sure that the transition of a from a state to another happens straight away, and it doesn't wait until Atoms reaches a transition frame of a clip. Okay. So we want this just because we want to go straight away to our next clip. Then here what we want to do is we want to set a blackboard entry from array. So basically what we want to do is we want to pick a random state from a list that we're going to define now, and we're going to pick an element from that random list and set it as the state of the agent. One thing before I forget, is always very important how you lay out your behavior tree, simply because Atoms, iterates through the children, basically, and by using like a priority list, which is defined by how the connections are visualized. So basically, it's important how you lay out your agent, because you're going to start from top to bottom, but it's going to use the connection. So for instance, if you have a node that is like this, set up like this, it's going to of course evaluate this one and then this one, even though this one is at a higher let's say level, at a higher height than this one in the graph. Okay, so just make sure that of course always take this in consideration whenever you are laying out your behavior tree. Okay, so as I said, we want to create a new blackboard key. We're going to call it stand states, and this stand states is going to be an int array. So basically an int array is just a list of ints, and here we're going to add a certain number of states, which we're going to pick from the main stadium state machine. So we're going to always start from the stand state, so we could go both in this state and then stand applause rhythm, arms up, and watching. I won't really care about the others, so it's basically number 2, 3, 4, 5, and 8. So here is, I think it's 5, so 2, 3, 4, 5, and 8. So these are basically these are the IDs of those states that we just checked, and we're gonna pick like a random element here and set it on a metadata. So we're gonna pick the array blackboard key here, which is stand states, and we're gonna set it on the state. All right. Also, we're gonna select these two, so the use agent ID as seed and also use animated seed, which basically will randomize the selection of the element during the simulation a bit more, because basically we're going to use both the group ID and the animated seed as the time to randomize the picking of the element from this list. Okay, so then after this thing, we want to wait. So we want to wait one frame, and this is because basically here what we have set the transition clip, and it's set basically to true. So then we're picking a state, setting a state, and then we want to wait a frame until Atoms can really start the transition towards that state. And then after we waited, we want to make sure that this force transition clip is set, force clip transition is set to false, because we don't want this to happen all the time. Okay. So what we're gonna do here is we're going also to give some names here, because of course if you start having a lot of nodes, then you don't understand anymore what you have done. So here we're gonna call it stand state. Then here we're gonna call it set first to false. This one is set force clip to true. This one is set stand. This would be set stand state, but it's not really. But anyway, set random. Let's call it set random. send state, and this one is wait is okay, and then here we have wait one. Let's create wait one so it's a bit more clearer. Wait one, set agent metadata is set false, click to false. Okay, okay, great. So after this point, what we want to do is we want to make a new selector, and I'm going to explain to you in a second why. Here we're going to have another optional, and we're gonna set this to dynamic. So not optional, sorry, conditional. Sorry about that, conditional. And we're gonna set this to dynamic, and we're gonna also invert it. And here what we're gonna do is we want to make sure that the state is different from the current state. So let me show you something. So here, if I just create a grid layout of one agent, and I'm going to set the direction to -1, like this, so it's the other direction. If I go on the state machine and I set the state to 1 here, and then I set another keyframe here, and then I set another keyframe here. So here we are changing from one frame to another, the state from 1 to 10. If I press play, actually before that, let me add another metadata here, which is going to be current state. Now, so the first frame, the state and the current state are the same values. Current state is actually the state that is being played by the state machine, while state is the input state that we are providing, telling Atoms you have to go to this state, right? Okay, so state 1, if we press play, we see that the current state at this point is still 1. State, sorry, here is something that didn't work out. Here, 10. I forgot to uncheck this. So of course, Atoms wasn't setting the state because the set state on agent creation only was on. So we want to make sure that the state machine, just in this case, we're gonna reactivate this in a second, is off, so we can set the state at every frame. So you see at this frame we set the state to 10, but the current state is still 1, and the current state is gonna change just after a bit. Basically, when Atom is gonna reach a transition frame, and it can actually switch to the next state. So now you see that the current state and the state have the same value, but basically it won't happen for a while whenever we play a transition. So what we want to do here is we really want to give Atoms some time before actually, we want Atoms to wait, just to say it better, until it reaches the current state is equal to the state. So basically it means that whatever we gave as input is actually playing, okay? So if we go back in the Atoms UI, here what we want to do is we want to make sure that the state, I have also to expose the current state as a int. So this is again, it's like the state is an int, current state, and here the should be linked, okay? So I want to make sure that the state is, so it's an int, this current state. So the state is not equal to the current state. So basically we're saying until the state is not equal to the current state, we're going to wait. And we're going to wait for a while. So we're going to actually provide a very big number, let's say 2000. But anyway, this is going to, as soon as these two states, so these two values are going to be the same, then basically we're going to go to the next branch here. So what we're going to do here, we're going to set the state, set agent metadata, sorry, not the set agent metadata, it's the set blackboard key, blackboard entry to state, and it's going to be an int, and it's going to be 0. So basically we're actually setting again the state to the stand, basically. So let's call this one set stand state again, like this. Yes, okay. And also one thing that I did here, I set this conditional to dynamic because we need to check these continuously, okay, not just once. So if I press, if I save it, so I just press Ctrl S, and so I registered it, and I fix this, so it's back to what we did earlier. So okay. Now if I press play, we see our agents are actually, you see that they are starting at the first frame to 0, which is basically what we did at the first frame. Then after that, they switch on the second frame to another state, which is great, which is what we wanted, that this state is coming from the list. And because also we enabled the force transition clip, is gonna basically they're gonna transition towards the state straight away. And as you can see here, all the agents now are playing that animation. But as you can see, there's another thing that is going on. So we set the state to 5 here. For instance, let's look at this guy. So the state is set to 5, and as soon as the state sets to 5, we are setting the state to 2 here. So the tree is not us, but basically the tree, what we designed here with the tree, is doing this. There's going to be a problem with this, because if you check the state machine, you might know already that if 2 states are not connected, so for instance 5 is, let's see which one is 5, I think it's this one. 5, which is a stand arms up, is not connected to 2. So there's no way Atoms will be able to transition from this state to this state. Basically, the agent is going to stay in state 5 forever until we change the state, so that basically we can you know, the state that we're gonna give to Atoms is actually something that can be reached from this state. In this case, the only state that we can reach is state 0. If we check the debugger, so let me open the debugger. This is always very useful, you know, to check what's going on with the debugger. Okay, let me actually keep that open so we can see. So we're gonna check the agent 0. Let me show also the group ID here. Group ID, like this. I mean, you can of course select which agent you want to see. So this number here is actually the group ID here. Let's just check 0, which is down here. So basically, when you while you play Atoms, or while you move between frames, Atoms will show you which nodes are getting evaluated. So these ones with the green borders are actually have actually returned success. So it means that basically all these nodes have been evaluated by Atoms, but not this branch. Okay, so now if I go to the next frame, we see that now we have set the frame, we set the state here to 3, which is correct. This is the same thing that we see here. And now we're waiting 1 frame, which is great. Because of course we're stopping here because we're waiting that frame. Next frame, we're again here. So the following frame, we see here that we have both set the transition, the clip transition to false, and now we're at this stage here. Now, as soon as the 2 states are going to be the same, sorry, I missed that. I just went too fast. So there will be okay. So now at this stage, current state is equal to state. Okay, here. So now we do this, and actually, so we've gone through this state, but also we've gone back here. So basically, this is what we want. We want to prevent Atoms to go again through this branch here. Because otherwise here we're setting a new state. You see here is set state 2, which is not something we want to see at this stage here showing up state 0. So to do that, basically we simply have to wait again until the current state is equal to state. So let me close the debugger again. Let me open the Atoms UI. And let me create basically what we need is basically just these nodes again. And they will have to be just before this sequence. So let me move this stuff here. Let me move these ones here. This one will go there, and this one will go here. So I can press save. I can actually also create a comment node, and let's call this one. Actually, first expand it a little. Let's call this one set random states. Okay, like this. And I'm gonna save it. Now if I go back, so I just reset the simulation. Let's see what's going on. So state 3, now we're getting into current state and not 3, but state has turned to 0, which is great because basically we can go to state 0. If we keep going, actually let me set here the frame to a high value, so 1000 would be good. So this guy now, you see now it's turning to state 2, which is another state. I think this is the angry state. Now let's see where it's gonna go. Again, state 3. And of course it doesn't make sense that first it's angry and then it's uploading, but again you can make a different logic. Now it's watching, it's looking around. and it's great. So the whole thing about going back to frame 0 is because how the state machine is set up. All these clips, they have like the end frame, which is the same as the stand initial frame. They also have the same, end frame, all of them initial frames. So you could even connect them, and it wouldn't really make a difference. But just to show you how you can do things a bit, like even going back to state 0. If you are in state 0, especially, you could even go to sit. But also, anyway, because the last frame of the stand angle is the same as the beginning of the sit, you could even move to sit. Anyway, you can really change the state machine if you want. It's just how we laid it out, and yeah, basically, anyway, this is how you can customize a little your simulations. So let me just play it again. So let's check this one, for instance. Now it's current state is 8. We're saying go to 0. So as soon as it's 0, you should actually find another state, so 4. And so on. So all these agents are going to keep going. And this is great. Like if you just want to make like some randomization of your crowds, not caring about animating anything, just leaving, dropping your states there and making Atoms taking the decision for you, and you would be happy, by just having that, because maybe your camera is far away and your shot allows it, then you're very welcome to do it, and then you'll actually reach like a result like this one, which will give you a lot of randomization in your crowd. So okay, so this is it for this part of the video. Now we're gonna go on the next part where we're gonna drive the agents with an attribute from Maya. Okay, now what we're going to do is we're going to change our behavior tree so that we can also provide maybe a value from Maya, so from the one of Maya attributes, and then we can make the crowd react depending on that value. Okay, so we're going to go in the behavior tree again. We're going to move this stuff down because this is the last thing that we want to be evaluated. And first thing, we're going to expose that that attribute that is going to be in Maya and that we'll be able to use. Okay, so we're going to call this one action. Okay, action sounds good. It's going to be an int. Let's say an int is okay. This way, if you use an int, maybe you can have different actions depending on the value. So anyway, we're going to just use one value for now, but it should be okay. And the default value should be 0. Okay, and we're going to click on expose here, and this will actually make that attribute be exposed in Maya. So if now I go here and rewind, that value appears here in the as an attribute. So I can go here and set a keyframe. Let's go at frame maybe 40 like this. I'm gonna set another keyframe, and then following frame I'm gonna set 1. I'm gonna go ahead and give it some more frames, something like this. Set another key there, and finally the last key. So it's just in this section here, I'm telling to the behavior tree, you can cheer depending on the length of, basically on the frame range in which you're gonna keep that value to 1. You might have multiple cheers. I don't think we're gonna have multiple. It's gonna be just 1, because here we just have 40 frames, and our I think it's 10 score clip are way longer than 40 frames. But anyway, you can even have this value to set to 1 just for a frame, and that should actually trigger the cheering. Okay, so if we go back here, what we're gonna do is we're going to have a conditional as first thing, and we're gonna say if so we say this is an int. Okay, so if action is equal to 1, we're going to want this to be dynamic, of course, because we want to check this every time. And we're gonna say I want to set a blackboard key, okay, which is gonna be a new one that I'm gonna save here. It's gonna be called scream. Let's call it scream. Scream is good. The value by default is false. We're gonna set scream to true. Okay, this is because what I want to do is, like, I want to keep track of whenever we provide the action value set to 1, and then what we want to do is, like, we want to keep going at least until we have made one full cycle of cheering. I don't want the tree to actually stop while I'm doing that while I'm playing the standing score clips and go to the top, to the bottom part here of the tree. I want actually to make one full cycle so the animation looks good, okay? Also another thing that we need to do here is we're going to need to check that that shear is, the screen is set to, sorry, we can do this actually conditional. If you drag and drop, this should actually build the connections, which is a bit quicker. So equal, we're gonna say if that was a bool, so that if scream is false, because then basically we set it to true. So basically we're gonna go in here and it's gonna set scream just whenever scream is not set to false. Let me set it again. Okay, so scream, okay. If scream is false, sorry, it's yeah, it's false, then we set it here to true. So then here what we want to do is we want to make a conditional, again, a conditional if scream is true, okay? So again, here we set it to true. Basically we're gonna go here straight away and we're gonna keep going until that scream value is true. Basically at the end of this branch, what we're gonna do is we're gonna set that scream to false. So let's do it straight away. Actually, let's say here set scream to true, and then we copy this one. I'm gonna paste it here. This is gonna be again our last stuff that we do, and we're gonna say set scream to false. Okay, great. So that's there. So basically what we want to do in this branch is to play that the standing score clips. So if you go in the state machine, is this one. So the ID is 7, okay? So we'll have to remember that. We can come back later anyway if we forget, just because there are gonna be, we're gonna add some more nodes before we actually get there. So what we want to do is like we want to make to perform some nodes in a sequence. And actually I did something wrong. I should have connected this one there. Okay, then what we want to do, the first thing is we want to set the force clip transition to true, this one here. And another thing that we want to do is we want to set another metadata that is called let me check it here from the docs. It's basically, this is the name. We want to set it to a value which is in this case 30. Okay, so what this does is, actually let me, before I forget, set transition blending frames. Okay, I'm gonna connect it here. So what this does is if we play the animation, actually let me disconnect this one, it's gonna make more sense. We're gonna set the stand state. If I should have the set stand state again, this one. Just because basically what we want to do is we want to go on the stand state at the beginning. So maybe we're playing an animation which is maybe the clapping or an angry state. What we want to do is we want to go straight away in the state in the stand state. Then we want to wait a frame. So wait, and it's gonna be 1 frame. Let's call it wait 1, and then we are going to set the force clip to false. So that's this one. We should have another. This one. It's basically the same thing that we're doing down there. Okay. I'm gonna show you why this is not gonna be great. Look great. So save. Okay. So if I go here, if I rewind, press play. You see basically what happened there. Like they went to the stand state very quickly. Like it was like probably in just a few frames. So this is because of how the state machine is set up. The state machine is set up so that basically all these connections, they have very little blending frame values. So if you force the clip transition you know, like sorry, if you have this force clip transition set to true, Atoms will actually blend straight away from the stand angle, stand up all these states to the stand straight away without waiting for the transition frame, which means that maybe the arms of our agents, as we're seeing, they could be like up in the air, or they could be just in front of our agents. And then, you know, if you basically blend that pose to the idle, to the stand pose in 3 frames, you're never gonna get a nice result. So the purpose of this node here is actually to give Atom some time. So we're gonna say basically use 30 frames for blending. So you have, of course, to provide the right name for the metadata. So basically by providing this to 30, you are actually saying to Atoms to use this metadata instead of the value that we have here on the transitions, okay? And this is just happening for the blend in, okay? We can also use it for the blend out, but in this case we just need the blend in. One important thing though is that you have to make sure that you set this back to, actually you delete this metadata after you have finished using it, because otherwise if you keep this on, and if you keep it on the agent, then basically you end up having all the transitions being played with 30 frames, which is maybe not something that we want necessarily. So if I rewind now and press play, you see now it's much smoother, okay? I mean, it's okay, you know, like it's a decent result, okay? It's much better than before anyway. Okay, cool. So we have that transition going on. So now what we want to do is, so we've set the for script transition to false. Now what we want to do is we want to do something similar that we have done here. So we're gonna copy these nodes here and also these nodes here, because what we want to do is we want to make sure that we can go to that, let me have some more space here. We want to basically to go to that state that we just said, the score state, okay? So the score state again, I think it was 7, just to make sure I didn't remember correctly, 7. So basically here we say wait until we reach the state, the current state. So because we have that, you know, those 30 frames happening before we actually reach that, actually reach the next state, which is like the standing state. We need to wait. Then we set the, sorry, no, we don't need this one because we don't need to set the random transition, sorry, the force clip again, because we're going to complete it straight away. What we're going to do though is we're going to delete that, delete agent metadata, this stage, which is the one that we were using here. So we want to delete it at this stage. You don't delete it here or even during this, inside this conditional, because we have to wait until the transition is finished. So only at this stage you can delete it, okay? So then we're going to say, we can set the, straight away, we can set the blackboard key entry. It's gonna be the state, and we set int, and it's 7, okay, great. Okay, so this should be okay if I save. And now what I want to do is actually, after this is finished, I want to go to the stand, okay? So I'm just gonna copy this stuff again, and I'm going to do this. So we have the wait, and then we want just to set the, I don't really need this one. I just need to set the state again like this. And here we delete that flag, okay? One other thing that we want to do before we continue is we want to make sure that we never get into this how do you say, into this branch before we actually are finished with this one. Okay, so in order to do that, because it could be that maybe here one of the nodes is running, so we're waiting, but then basically the behavior tree decides to go in here, and if it finds maybe you know, some success node here, so basically we are breaking effectively here the computation of this branch, which is not something that we want. To do that, basically what we have to do is just to say, don't go in here, I mean go in here just when screen is false, okay? Quite easy to do that. We can make this one a bit bigger, move these nodes here and this one here, okay? Great, so if now I press save, we can play again the animation. And now they're cheering, you see, which is great. So we can even check what's happening in the debugger. We go in the behavior tree here. Let's see, so first frame is this. Okay, first frame is that one. We go ahead, second frame we are here. So here, of course, we want to be while the value is 0 of action in this branch. Okay, now we're here, which is great. Like you see here in the frame range, the action is actually 1, so this value has been passed to the blackboard, and now it's evaluating that. So also screen is set to 1. Great. So now we're waiting. I think that transition happens. Now we have set the state to be 7, which is great, but the current state is still 0, of course, because we're in standing. In the stand state. Now go ahead. Now you see action here has turned 0 because we are in this section of the. Actually, sorry, I should have done that before. Let me press play. So action is still 1 there. Okay, now it's 0, but screen is still 1. So because we are here and we are waiting for the cheating clip to finish. Actually, it hasn't even started yet. So then basically after a bit, screen becomes 0, but we are still playing that that clip. Okay, so now of course we were basically saying we are just setting the value to 0, so that's basically what's happening here. So the state was set to 0, so we're waiting at this stage again after screen has been set to false. And then once we get back to the state at 0, we then start randomizing again the states. Okay, you see now again the states are getting randomized, and of course if you had like these value still at 1, so the action attribute still at 1, here we would see the crowd still cheering. Okay, of course here you can, what you can do is like you can create multiple branches. You can have you know, like even a different logic to make sure that you can handle different actions. One thing though that you might have noticed already is that whenever they start screaming, let's say, they do it all in sync, which is something that maybe we want to avoid, because of course this is not going to look realistic. So we can maybe add like some sort of delay to our agents. To do that, we need to go where we actually set the state, the state of the screen here. So we can wait here some time. So what we're gonna do, we're gonna generate a random value. So this is gonna be a double metadata, and we want to save it. Basically, the value that is gonna be generated by this node is gonna be saved on a blackboard key again. So let's create one. Let's call it wait time. It needs to be a double like this, and I'm going to set this one here. Then we are going to provide two values here. So if you use if you leave this off, so use absolute distance, the value is going to be calculated in this way. So you're going to provide a center, let's say 5, and then like a distance here. Okay, so the value is going to be for if this is off, be calculated between minus, like 5 minus 10 and 5 plus 10. So in this case will be minus 5 and 15. If instead you say if you use the absolute distance, it's going to be just between 5 and 15. Okay, so in this case what we're going to do is like we're going to say maybe 0 and 30. I'm going to use the agent ID seed and also the animated seed. So we're both using the agent ID for having a better seed, but also the time of the sim. And then here what we do is like we do wait. So we're going to wait, but we're going to wait the time that is given by the wait time. Okay, so if everything is okay now, if we go back, we should see some delay. So not all the agents will start playing together. Okay, so we have still some agents playing together, but at least it's better randomized. Okay. Okay, so anyway, this is just an example about how you can use the behavior tree with your stadiums. If you just care about having them, playing some random clips or random states, you can just, make and changing state as well, so they don't play always the same state. You can just use, the top part and the bottom part of the tree. If then you want to do something a bit more complicated, then you can use the, this kind of logic. Otherwise, like you can still use the standard. If you're happy to do everything manually, you can use always the standard modules. But anyway, with the behavior tree, you'll see that basically you can randomize things a bit better. Okay, so this is all for this video. I hope you enjoyed it, and see you in the next video.